In this video, we will be solving a right triangle given two sides. In earlier videos, we dealt with the following triangle on the right. We can now determine all sides and angles in triangle ABC. Earlier, we discovered that angle C was 36.9 degrees approximately. So angle A is 90 degrees, subtract 36.9 degrees, meaning angle A is 53.1 degrees. Angle B is 90 degrees. Angle C is 36.9 degrees approximately. CB equals A is 8. AC equals B equals 10. And BA equals C equals 6. Since we have determined all sides and all angles in triangle ABC, we say we have solved triangle ABC. Solving a triangle means to determine the measures of all angles and the lengths of all sides in a triangle. Here's the tools in our toolbox. We have the primary trig ratios beginning with tan, sine, cosine, and of course, the Pythagorean theorem. Here's example 1. Solve triangle LMN and state all measures to the nearest tenth. Let's start by finding angle N. For angle N, we have the opposite and the adjacent. So the ratio to use is tan. Tan is the opposite divided by the adjacent, which gives us 24/7. To find the angle, we do the inverse tan of 24/7. We get 73.739795 continuing. Rounding to the nearest tenth, we get angle N is approximately 73.7 degrees. Angle N plus angle L equals 90 degrees. So angle L is 90 degrees, subtract 73.7 degrees, meaning angle L is approximately 16.3 degrees. We have all three angles found. Now we just need the hypotenuse Ln, which is little m. To do that, let's use the Pythagorean theorem. Ln squared equals nm squared plus Lm squared. If Ln is little m, then we can also write it as m squared equals L squared plus n squared. So we have m squared equals 7 squared plus 24 squared, m squared equals 49 plus 576, m squared equals 625. Taking the square root, m is the square root of 625, or 25. So now we have angle L is 16.3 degrees, angle M is the right angle 90 degrees, angle N is 73.7 degrees. NM or little l is 7, Ln or little m is 25, and Lm or little n is 24. We have determined all angles and all sides in the triangle. Thus, triangle LMN is solved. Here's an alternate solution. Now that we know angle N, we could use the sine or cosine ratio to find the hypotenuse. Let's use sine. Sine 73.7 degrees is the opposite divided by the hypotenuse. This is N divided by M. We get sine 73.7 degrees equals 24/m, since little n is 24. Writing this as sine 73.7 degrees over 1 equals 24/m, and cross multiplying, we get 1 times 24 equals m times sine 73.7 degrees. Rearranging, we get m times sine 73.7 degrees equals 24. Isolating for the variable, we divide both sides by sine 73.7 degrees. And these cancel because this is just equal to 1. This gives us m equals 24 divided by sine 73.7 degrees. We can take our calculator, and 24 divided by sine 73.7 degrees equals 25.005,07155 continuing. So m is 25.0 to the nearest tenth. We now have angle L equals 16.3 degrees, angle M equals 90 degrees, angle N equals 73.7 degrees, NM or little l equal 7, Ln or little m equal 25.0, and Lm equal little n equal 24. We have determined all angles and all sides in this triangle, thus triangle LMN is solved. Here's some practice. Solve triangle PQR. State all measures to the nearest tenth. You may wish to hit pause here and try this on your own. Since we have the hypotenuse, we could use sine or cosine to find angle P or angle R. Let's focus on angle P. With respect to angle P, we have the adjacent little r and the hypotenuse Q. So we choose cosine. Cosine of angle P is the adjacent, 6.4, divided by the hypotenuse, 9.8. So we solve cosine P equals 6.4 divided by 9.8. Angle P is the inverse cosine of 6.4 divided by 9.8. We get 49.227,19531 continuing. Rounding to the nearest tenth, we get angle P is approximately 49.2 degrees. We know that angle P plus angle R is 90 degrees. So angle R is 90 degrees, subtract 49.2 degrees. We get angle R is approximately 40.8 degrees. We have all three angles found. Now we just need the leg QR or little p. Now that we know all angles, we could use any ratio to find QR or little p. But let's use the Pythagorean theorem. PR squared equals PQ squared plus QR squared. In other words, little q squared equals little r squared plus little p squared. We can manipulate this to solve for little p squared, and p squared equals q squared subtract r squared. We get p squared equals 9.8 squared, the hypotenuse, subtract 6.4 squared. P squared is 96.04, take away 40.96. We get p squared equals 55.08. P is the square root of 55.08, and p is approximately 7.4 to the nearest tenth. So now we have angle P is approximately 49.2, angle Q equals 90 degrees, angle R is approximately 40.8 degrees. QR or little p is 7.4, PR or little q is 9.8, and PQ or little r is 6.4. We have determined all angles and all sides in the triangle, thus triangle PQR is solved. Please proceed to the next video in this lesson, and thank you for viewing.